Have you ever wondered why some algorithm runs faster than other algorithms? Why sometimes when you submit an algorithm, it gets an time limit exception error? In this video, we'll talk about how time complexity works in actual algorithm, and also we'll talk about how you can optimize the algorithm. There are a few tips how you can use those in your real life during a programming interviews. Hey, my name is Imran. I'm working as a software engineer since 2013. I solved more than a few hundred LeetCode problems and got an offer from Microsoft, Amazon, Oracle in the past. I love teaching computer science programming courses. If you are preparing for a coding interview and new to this channel, consider subscribing. What is time complexity? Time complexity is the computational complexity what computer takes to execute a program. When you are trying to execute a program, based on the input size and algorithm, it might take few milliseconds to few seconds, sometimes even hours. So in the case of time complexity, we want to measure how efficient our algorithm is and also how we can optimize those scenarios. So why time complexity matters? Because based on the scenario, sometimes when you are trying to execute a computer program, sometimes it takes way longer and sometimes it takes very limited amount of time. CPU time and memory are limited resources. So let's talk about how we can analyze the time complexity. So if you're trying to execute a program, let's take a look at the simple number array. So if we are given a number array, integer array of any numbers. If we want to print all the numbers from an array, we can write simple algorithm to just print these numbers, right? So you can write for any nums, you just want to print all the numbers. So if you have only 6 numbers in this array, it would take 6 units of time to execute this whole algorithm, or basically these 2 lines of code. What will happen if you have millions of numbers? It will take millions unit of time to execute this part of your algorithm. Take a look at the another examples of two-sum problem. So if we are given this algorithm and we have a for loop which will execute from all the numbers, basically I, n in enumerate nums, we want to go through the for loop. So it will take order of n time, basically n unit, some multiple of n unit of execution time. So that is actually time complexity. For the case of conditional execution, we always assume that it takes 1 unit of seconds. And for the space complexity, how much space you are using when you are trying to execute an algorithm. So for this case, analyze time complexity, we have seen a dictionary which in the worst case might store n number of elements, so it will be an order of n. Let's look at a time complexity chart. So for the case of given n number of inputs, we want to draw a chart where in the x-axis we have the number of inputs and the y-axis would be the order of growth. So if it's a logarithmic scale, it will be something like very near to the x-axis, and we'll use different colors to show how does it look. So if we have order of n algorithm, it will take something like this. For the case of order n log n, it will be something like this. Let's talk about different types of time complexity. When you're trying to measure time complexity, sometimes you measure the worst case analysis. That means in the worst case, how long will it take to execute an algorithm? Sometimes you only consider average case, because if the worst case is not that much frequent, and you can consider also the other part. Worst case analysis, basically we use order of n. For the case of average case, we typically use theta of n. And And sometimes you use best case, which is we'll use omega of n. So this is the average case, and this is the best case. Let's talk about some common data structure time complexities. So as you can see on the chart, for the case of array, stack, queue, linked list, hash table, and binary search, we have different amount of average case time complexities and also the worst case for space complexities. So what it means for the case of array, it's theta 1. So it usually takes constant time to access an element from an array. And all the elements of theta n means actually it's linear time. So if you have n elements, it will take multiple of n units of time for the case of search. And for the case of worst case, space complexity is always O of n. That means in the worst case, you will have n unit of space required. And if you take a look at the last row of this chart, that is binary search, all of them are log n, which is a better data structure to use if you can use it. Most of the cases, if it's a sorted element, you can use binary search. Let's talk about common sorting algorithm, time complexity and space complexity. When you're trying to execute a sorting algorithm, based on the algorithm you use, the time complexity varies from algorithm to algorithms. So if you use like bubble sort or insertion sort, in the worst case, it might take order n square, which is quadratic. But if you want to move to little bit more efficient sorting algorithm, as you can see in the chart, like quicksort or merge sort, you can do the sorting with n log n. For the case of quicksort, it's the average case of n log n, and in the worst case, still order n square. And when you are trying to use this type of sorting algorithm, it will save you a lot of time. One of the special type of sorting algorithm like heap sort, which typically takes theta of n log n, and you can do using space required order of n based on the number of elements you have. So if you can use heap sort, that would be pretty efficient algorithm based on the use case. Now let's talk about how you can optimize your algorithm. So I'm giving you some list of tips what you can try. As you can see on the list, at first when you are considering an algorithm or coming up with an algorithm during a programming interviews, the first thing you need to consider, how bad is the current algorithm? Is it order n square or n log n, or even worse than that? If it's like order n square or n log n, there is always a chance you can optimize a little bit more. But if you start with order of n, most likely you might not have that much of space or actually opportunity to optimize. Another tips, can you use an efficient algorithm? So basically, if you are using something like bubble sort, can you use quick sort or merge sort to optimize the algorithm? Can you store something to use it later? So for example, for the case of two-sum or Fibonacci problem, what might have happened that you have some sort of opportunity to save something which you can use it later. Can you use an efficient data structure? For example, if you are using queue or stack, can you use double-ended queue, or can you use heap data structure, which might efficient or which might speed things up? Or can you reuse the space what you already used? So if you look at the problem, how we solve product of an array, you can optimize these algorithms based on the space uses. Now let's take a look at the cheat code, what you can use when you are solving coding problem in the interview. As you can look into this chart, the time complexity, if your time complexity order of n and space required is order of 1, this is the best case you can come up with during an interview. But if you start with order of n square is the last row of this table, and order n or order 1 time, you should think about how we can optimize this better to use it in the algorithm makes sense. Now let's talk about the next step. So if you like this video, watch the other videos I have created for two-sum and best time to buy and sell stock, where I explain more how the time complexity works for each of working algorithms. You can practice more LeetCode or HackerRank types problem You can subscribe to the channel if you want to learn more about computer programming concept.